Hi, I'm Will Lehman, and I'm here to present on comparing consequence analysis in HEC-WAT to FDA for the FDA prospect course. In HEC-FDA, each damage reach takes the process of aggregating stage damage functions. So those aggregated stage damage functions will reflect two primary components. One is the inventory itself and the uncertainties of those individual structures in their damage relationships and their attribution associated with value or other attributes. But it also takes into account the water surface profiles for, in FDA's case, usually it's about 8 profiles. So those 8 profiles are encoded into the damage function. Their relative distance from one another at any location along the reach is fixed. It doesn't change. So if there is a different shaped hydrograph that comes down the channel, that doesn't get reflected at all in FDA. It's encoded directly into that water surface profiles. You can see my water surface profiles in the gradiated lines or the different dashed lines that I've labeled on this image above. What happens is for each of those profiles, the damages are computed and they're aggregated to a centralized location, and that occurs for every single profile, and we create an aggregated stage damage function. All the uncertainties are sampled, so that ultimately will be described with uncertainty, but there is no uncertainty in variation of those relative distances for the stages reflected by those profiles. So it's a limited scope. If the coincident flooding of 2 different reaches changes the attenuation of the hydrograph at a location, you could get a very, very different stage damage relationship at a location under certain conditions. It's not always a big deal. Sometimes it's not a big deal at all. What we instruct you to do with damage reaches is to make sure that they're hydrologically separated. If they're hydrologically separated, then the impact of this assumption is smaller. But that helps to mitigate an issue that's underlying how aggregated stage damage functions work. When we get into WAT, remember we're running an event-based analysis, so every event is unique. Each event represents the geospatial domain of depths everywhere, and our structure inventory is geospatially distributed, and all of the uncertainties associated with those structures are sampled at the time of compute, and the damages associated with that particular event are computed. And then we just do that a whole bunch of times, once for every event. So it's done dynamically on the fly to calculate the losses at an individual structure. If you wanted to think about each structure being its own aggregated stage damage function, that's a way to think about it. But in general, we are not aggregating. We're calculating the uncertainty in EAD at each structure and able to aggregate that up as a post process. So that's one big difference between the WAT and FDA regarding consequence estimation.